Okay, so this is day 2 in the probability unit. It's called counting elements of sets, and we're dealing with Venn diagrams. It says in a Venn diagram, circles are used to represent sets. When circles overlap, this is known as their intersection. The and relationship in a Venn diagram. So we're going to be talking about this in probability. It says the intersection of two sets consists of the elements that are common in both sets. When we say the intersection of something, we denote it A intersection B. The intersection of sets is shown by this symbol. So this means what they have in common. So what is in common between A and B? Okay, so let's apply it to an example. There's also or, which is this circle of something and this circle of something. So or is containing all of them. Intersection is and, or is a union between them. So before we used and, it's what they have in common. Or represents the union or the joining of both sets. In a Venn diagram of the union of two sets, the whole circles are shaded, meaning everything between both of them. So here's an example. We have set A, which is 1, 2, 3, 4, 5. And we have set B, which is 2, 4, 6, 8, 10. Their intersection, or what they have in common, is 2 and then 4. So that's their intersection. Their union is all of them. So say A decided to move in with B. Well, what stuff do they all have? Okay. 1, 2, 3, 4, 5. We already have the 2. We already have the 4, but we have also 6, 8, and 10. Okay. All right. Now, these notes are for your benefit. Some of you are turning the notes into me. I don't need the notes. It's just for you to understand the lesson. Okay. Disjoint or disjoint sets are when two Venn diagrams have nothing in common. Their intersection is empty. So here is a set of even and odds, numbers 1 through 10. So if I make a Venn diagram and I make this circle the odd, so I draw a circle and then I draw another circle overlapping it. I would put 1 where the odds are, and I would put 2 in the evens. So 1, 2, 3 goes in that, 4, 5, 6, 7, 8, 9, and 10. Notice they do not share anything. Okay, and there's a little cartoon. It says, I'm sorry, Cornelius, but I just don't see us ever becoming a Venn diagram because they have nothing in common, and he's heartbroken. Okay, so here's a summary. There's an intersection where it just talks about what they have in common. A union is all the things they have combined, including their intersection. And disjoint means they have nothing in common or it's just blank. Okay. All right, last page. So now we're applying it to probability. It says counting elements of sets. Suppose you have m elements in a set M and n elements in a set N. The total number of elements of the two sets is m plus n minus t, where t is the number of elements in their intersection, saying you don't count their intersection twice. So for example, they're saying if we had here, you wouldn't count 2 twice, you just count it once, okay? So you're playing a card game with friends. The next card you play is either a queen or a heart. How many cards can you play? Or what's the probability you get a queen or a heart? Well, you have 4 out of 52 cards are queens, and then 13 out of 52 cards are hearts. But you have to subtract any cards you counted twice. Well, we know that there is 4 queens. Queen of hearts, queen of spades, queen of clubs, and queen of spades, queen of diamonds. So there's 4 queens. And then there's also, in the hearts, ace, 2, 3, 4, 5, 6, 7, 8, 9, 10, jack, queen, king. So 13 hearts are here, 4 queens are here, but the queen of hearts was counted twice. So you have to subtract the cards you count twice. So how many cards can you play? Oops, why did I write 2? I wrote 1. It's 1 card. It would be 16 cards you could play, or the probability would be 16 out of 52. So it says you try. So go ahead and pause the video, and then you try the next one. It says you are playing cards with a friend, and the next move they can make is either a king or a spade. How many cards can your friend use? Well, I have 4 kings, and I know there's 13 spades in a deck, but I counted the king of spades with the king, and I counted the king of spades with the spades. So that king of spades, I counted twice, so I have to remove it, and you get 16. Okay. All right, let's try it again. It says if M and N, so this is pretty much what it's saying. If there's no cards that overlap, you just add them together. But if we had one that we counted twice, we subtract it. So it's just a formal way of writing it, subtracting their intersection. So here, let's try it again. If you have a stack of cards in front of you and you pull a card at random, what is the probability the card you draw is a queen? Well, there's 4 queens in the deck, so that would be your answer. You'd reduce it and make it a percent if you wanted to. It depends on the directions. This one says, what's the probability the card you draw is a king or queen? Well, we saw in here, you add the 2 probabilities together. So the probability you're a king is 4 out of 52. The probability you're a queen is 4 out of 52. Then it said you subtract if there's an intersection. So is there an intersection here? Will a king ever be a queen? No. So there's nothing to subtract. So your answer is 8 out of 52. And you'd reduce it. It says, what is the probability the card you draw is a spade or a 4? So what's the probability you have a spade or a 4? Well, there's 13 spades out of 52. And there is 4 fours out of 52. And it says to subtract their intersection. So when will a spade ever be a 4? Once, the 4 of spades. So you have to remove it. And you'd reduce. Okay, it says you try. So go ahead, pause the video, and you try it. All right, it says, what is the probability the card you draw is a jack or queen? So a jack is 4 out of 52, and a queen is 4 out of 52, and it's 8 out of 52. All right, so these will never intersect, ever. Okay. What is the probability the card you draw is a queen or heart? Well, a queen is 4 out of 52, and a heart is 13 out of 52. But will they ever intersect? Yeah, the queen of hearts. Now, you're going to see 16 out of 52 is common with problems like this, but it's not always going to be just -1. It could be -2 or 4, whatever. And then I'm going to attach work for you guys to work on. I didn't put anything up yesterday just because only like 2 or 3 kids handed in everything so far. I just gave you data, catch up. I'm going to put an assignment in today. And then I don't think I'm going to put anything up tomorrow. And I'm just going to start. I made phone calls yesterday, and I think I'm just going to touch base with everybody who's missing some things. And I've done some Zoom calls with some of you guys. So if you're struggling on your project, let's do a Zoom call. If you're struggling in other areas or just feel overwhelmed, let's create a schedule. Let's talk about it. I will be reaching out. So this week is Tuesday and Thursday. I think I'm only going to have maybe 2 or 3 assignments. So if you're like, am I missing something? No, you're not. Always check Infinite Campus to see what assignments you are missing or what they are. And like I said, I don't need your notes. Some of you are sending them in as an assignment, and they're not. So this isn't the assignment. This is for you to understand the lesson. Please let me know if you need anything. Thanks, guys.